Hi everyone, this is Dr. Kiranmayee, working as professor in the Department of CSC and also taking care of the technical trainings at VNR VJEC. So today I am going to discuss about the cues and also a detailed lecture on linear cues. So when you look about these particular images, okay, so first one is a library counter. So in front of the library counter, all the students or the who wants to issue a book or else who want to renewal a book are standing in a line. And the next figure, if you are going to see, it is a one-way road where the vehicles are moving in a one-way direction, where the vehicles are not coming in the reverse direction, means they are kept in a queue. Now coming to the third image, it is an ATM center where we want to, whenever we want to withdraw the money or else when you want to deposit, whatever may be the case, all of us will be forming a queue. So in all this case, here, all of us are forming a line, means there are two ends over there. So two ends in the sense, one end is used for what? Adding. And other end is used for what? Deleting. Right? So this is nothing but the concept of queue. So queue is a linear data structure which has two ends where insertions are done at rear end and deletions are done at the front end. So means there are two ends called as a rear and the front, and rear additions are done and where front is used for deletions. Now, the principle followed over here is the first come first served. That is, the first entered element will be the first one to come out. So whenever you observe a particular queue, right? So from the rear end, you are going to insert the element. Suppose 10, 20. So this end is called as a rear end. And deletions are only possible from the other end called as a front end. So now front will be over here and the rear will be over here. So now they take this example here where the elements are inserted from 3 to 8 from the rear end. Now if you want to perform any deletions, the deletions can be performed only from the other end called as the front end. See here, the insertion operation in case of a queue is called as an NQ operation, whereas the deletion operation in a queue is called as a DQ operation. Coming to the types of queues available, the first one is simple queue or is also called as linear queue, and the next one is the circular queue, priority queue, and DQ means it is a double-ended queue. So today we are going to see what do you mean by a linear queue and what are the various operations you can perform on a linear queue. So before going to the performing the NQ and the DQ operations, so we would like to know what are the various applications of queue in computer science. The first one is the CPU scheduling, means whenever we want to execute several tasks, suppose we are going to input several tasks to a machine. Then suppose 100 tasks you have given to the machine. Now what the CPU is going to do is it is going to execute the task one by one because it cannot handle all the tasks at a time or executes only one by one. So it is nothing but use the concept of first come first serve. The first entered task will be the executed first. Next comes the job scheduling. The best example is suppose take a printer. The printer, we want to print, suppose 50 documents I want to take the print. All these 50 documents at a time, we cannot take the printouts. So these 50 documents will be kept in a queue. Then you're going to take the print one by one. means you are using the concept of queue over here. Now coming to the networking. Networking here, the sender takes sender and receiver. So here you want to send some messages or some data from the source to the destination or from the sender to the receiver. Here huge volumes of data, if you want to send it from the source to the destination or source to the sender to the receiver, then all these data or the huge volumes of data will be kept in a queue. Then it will be sent one by one to the receiver. So here also you are using the queue in case of networking. Now the buffer management. Buffer management means here it acts as a temporary storage. Okay, so temporary storage means queue acts as a temporary storage whenever one side the slow devices are there and the other side the fast devices are there. In that particular case, temporarily all these particular data will be kept in a queue. So this is what you mean by the buffer management. So all these are the applications of queue. Now coming to the abstract data type of a queue. So in the case of abstract data type, we are going to list out what are the various operations you can perform on a queue. So this queue here, it nothing but it creates an empty queue. Next, enqueue. So just we have discovered that enqueue is nothing but an insertion operation in a queue. So it is going to insert an item into a queue. Dequeue operation is used to delete an element or remove an element from a queue. So this is a dequeue operation. Is full. Is full, it is going to test whether the queue is full, means contain the size of the queue is equivalent to the number of elements and no further you are going to add any elements to it. Now is empty. You're going to check whether the queue is empty. So whenever a queue is empty, you cannot perform a dequeue operation over that. So that's why make a habit of checking is empty whenever you want to delete an element from a queue. Get friend. I want to find out what is an element present at the front end. So you can done it using get friend operation. Get rare. This is going to acquire the data element present at the rear end. The size is going to say what are the number of elements currently in a queue. This is about the ADT of the queue. Now coming to the linear queue. The first type of queue is a linear queue. Now consider a queue size of 5, means the capacity of this particular array. We are going to implement the linear queue using array. Now take an array, call it as a linear queue, size of 5 elements. So the initial values of the linear queue are, we are initializing front equal to -1 and rear equal to -1. Now I want to perform an enqueue operation, means wants to insert an element into a linear queue. When I say enqueue of A, then you are going to increment your rear. So here rear is equal to rear plus 1, and also if at all your front is equal to -1, make it as front equal to 0. So whenever you want to insert an element, so increment your rear, then place an element at that particular position. So now the values of front and rear are 0. Then again I say enqueue of B. So B I want to insert. So always you are going to insert at the rear end. So increment the rear, then place the element. You're still, your F is pointing to A and R is pointing to B. Again I say enqueue operation. So insert rear. So F is 0 and here R is over here. That is front and rear. Again insert, your rear is equal to 3. So your rear is over here and your front is here. Again I say rear, increment the rear and the element is occupied over here. So here front equal to 0 and rear equal to 4. Now I say I want to insert an element into this linear queue F. Okay, so now, but the size of the particular queue is equivalent to the number of elements present. Now, F cannot be inserted over here. Already, your linear queue is full. Means, whenever you want to perform an NQ operation, check the condition whether the queue is full. So, when the queue will be full, linear queue is full, whenever your rare is equal to max minus 1. Max minus 1, why? Because we are starting an array from 0. So 4 is max minus 1. Whenever the rare reaches the max minus 1, means your queue is full. So you cannot insert an element into the linear queue. Otherwise, what you're going to do, simply increment your rare and then place the element at the particular position. Next example is for performing the DQ operation. Okay, so DQ means deleting an element from a queue, linear queue. So initially your F, that is friend, is here and the rare is over here. I want to delete an element from a queue. So always the element from the front side, because insertions are done at this particular end and deletions are done from the front end. So what you're doing, you are deleting, okay, means delete an element and you're incrementing your front. So that is why F is equal to 1. So first delete and then you are going to increment your front. Front is equal to front plus 1. So similarly perform DQ, again DQ, again DQ. Now in this particular case, here friend and rare are equal. So always check whenever friend is equal to rare, means one element exists in a linear queue. So again, when you want to perform a DQ operation, delete it. Okay, after deleting this particular element, set back the friend and rare to minus 1. Okay, so friend is equal to minus 1 and also rare is equal to minus 1. Now, again, if I want to try to perform a DQ operation, here you cannot, underflow condition exists. So what is an underflow means, already your queue is empty, then I want to still perform a deletion operation. So it's not possible. So in this particular case, when is your queue underflow, means if at all your friend double equal to minus 1. So whenever friend is equal to minus 1, your queue is empty and you cannot perform a deletion operation. Now, this is an algorithm to perform an NQ operation. So Q is the name of the array, because array, you are assuming it as a queue. Now item, this is a element I want to insert into a linear queue. So I told you that whenever you want to insert an element into a linear queue, first check for the overflow condition. Means check whether your queue is already filled. If check for is full. So is full means what? The condition is if rare equal to minus 1. If at all your rare is here, your rare is pointing to over here, you cannot insert an element into this particular queue, right? If at all friend equal to minus 1, set friend equal to 0, because whenever you want to perform an NQ operation and after that when you want to perform a DQ operation, then you have to set friend equal to 0. So here friend, set the friend to 0. Otherwise means some space is available over here, that is where suppose 30, here it is a rare. Then what you're going to do, increment your rare. First increment, then the item. Suppose 40 is the item to be inserted. So increment the rare and then insert 40 over here. And always this is nothing but the index of this particular queue, right? So make it a habit of always whenever you want to perform an NQ operation, check for the overflow. If at all, if this is false, then just increment the rare, then insert an element into this. Then this is an algorithm for performing a DQ operation, that is a deletion from the queue. So deletion from a particular queue, suppose your F is here and the rare is here 10, 20 and 30, right? First check for the friend minus 1 or else friend greater than rare. So in this particular case, your F is, this is false. Then what you're going to do, first delete this one and then increment your friend, means your friend is equal to friend plus 1. Next again, here I want to perform a deletion operation. See, first delete and then increment the friend. Here friend and rare are equal. Whenever both are equal means one element is existing. After deleting 8, your F is equal to minus 1. So whenever F is equal to minus 1 means what? Your Q will be empty. Or you also another case, F is greater than rare, that is friend is greater than rare. There is a situation whenever you have suppose 10, 20 and here 30, this is rare and this is friend, right? So now when this condition arises, when friend greater than rare means first delete, increment friend, then delete, increment friend, then delete, increment friend. So here F is here and R is here, friend is here and rare is here. So 0, 1, 2, 3, 4. So here rare is 3, friend is 4, means your friend is greater than rare. In this situation also your linear queue will be empty. So if this condition arises, again this condition also, both of them you set it to friend and rare, both set to minus 1. So whenever you perform a DQ operation, first check for the underload condition, and otherwise if your elements are existing, you delete it and then increment it. So keep it in mind, you have two conditions, either friend equal to minus 1 or else friend greater than rare for the underflow. Now display. I want to display the content of the stack, of the linear queue. So 10, 20, 30, 40 and this is the suppose current status of your linear queue. I want to display the content of this particular linear queue. So whenever you want to display the content, first check whether your queue is empty. When the queue will be empty, again what is an empty condition? Either F equal to minus 1 or else your F is greater than R, that is friend greater than R. So whenever the queue is empty, nothing to be displayed. Otherwise, from where to where you're going to print it? From friend to rare. You're going to display 10, 20, 30, 40. So that is the reason you initialize I to friend. So from friend, I less than or equal to rare till rare. You're going to print the content of the queue, means queue of I. Increment the I. So this you're keeping in the loop. So 1 by 1, 10, 20, 30, 40 from friend to rare will be printed in a linear queue. And what is the disadvantage of this linear queue? Here, whenever the friend is here and the rare is over here, right? So some amount of space is left over here where it is not utilized further. So this is the main disadvantage. Memory is wasted in a linear queue. In some cases, most of the memory will be, suppose only single element is there where friend and rare will be pointing to there. So this much of amount of memory will be wasted. So even the space is available, so we are unable to insert an element into these particular spaces. So this is leading to a false overflow condition also, and also inefficient memory utilization in the case of linear queue. So to overcome this disadvantage, we are going for a next type of queue called as circular queue. So the disadvantage of linear queue will be solved using a circular queue. So thank you everyone. We are going to have a next video on circular queue. See you. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.